So here we have a video on bar graphs. Bar graphs are graphs with bars, and they have a lot of information to share with us. So let's talk about them. When we're looking at bar graphs, we want to be able to identify the axes and their labels and know what those mean and how they relate to the data that we're looking at. We also want to be able to draw conclusions and make some predictions based on what we're seeing in the bar graph. Now, when we talk about a bar graph, what are some of the characteristics that we are looking at? First of all, a bar graph deals with what is called qualitative. That means non-numerical data. So we're not looking at numbers, we're looking at categories of things, like different types of fruit we looked at, or different types of vehicles that your teachers drive, or how many books everybody has on their shelf in their bedroom, okay? We're not looking at how many years you've been living in Delavan, or how many ice cream cones you have in your pantry. Those would all be numerical. Those are not qualitative. Qualitative is categories that are not numbers. The bars on a bar graph do not, all caps, touch, okay? If they do touch, that's a histogram and that's a completely different graph. A bar graph, the bars do not ever touch. There is no overlap between categories. Each category is self-contained and has no crossover with a different category. That's a super important thing to understand about bar graphs. Now, when we look at this graph here, we've got some scores on a pre-test and on a test. And we're talking about 4 different students here. We've got Jeff, Peter, John, and Mary, okay? What was the average score on the pre-test? So what we're asking is, of all 4 of them, what was their average score? Well, Jeff scored a 60, and Peter scored a 75, and John scored a 55, whoops, and Mary scored an 80. We're going to add all those up, and then we're going to divide by how many there are, which in this case is 4. So when I add up 60 plus 75 plus 55 plus 80, I get 140 plus 130, 270. I hope my math is right on that. Divided by 4. When I divide that out, I get 67.5. So the average score would be a 67.5 on this pretest. On the test, we can do the same thing. So we can add them all up. We can add up the 70 plus the 90, which is 160, plus Mary's score of 95, which is 255, and then add in John's score of 55, which is 310. Divide that by the 4 students, and the average on the test would be 70, 37, 0.5. Maybe check me with your calculator, make sure my mental math is correct here, okay? Now the question is, which student showed the most growth from pre-test to test? Let's talk about this. First of all, we can cross off John, right? He showed absolutely no growth. So John's out of the party. So who showed the most growth, Jeff, Peter, or Mary? Well, we can simply figure out the difference, right? Jeff went up 10 points. Peter went from a 75 to a 90, so that's 15. And Mary went from an 80 to a 95, also 15. So Peter and Mary both showed the most growth, okay? They both showed the same amount of growth from pre-test to test. Let's look at another graph here. This time we have cups of coffee sold. You can see that the number of cups is on the left axis there, and the month that it's being sold is on the x-axis. So the owners of Dunkin' just opened a new store in the mall. They tracked the coffee that's sold at both of their locations, as shown on the graph. Which store has better sales? So notice that the purple is their downtown store and the burgundy is their mall store. It's very clear that the mall store has better sales. Every month except for April, the mall store had better sales. So I'd say overall that store has better sales. You could also add them all up and figure it out, but it's pretty clear to see from the graph. Which month had the best sales? That would be February. February had the most sales. Why do you think that is? So let's make some predictions, okay? We're talking about coffee in February. Maybe because February is super cold, a lot of people are drinking coffee. Notice that in February too, the mall has a lot of coffee being sold. Maybe people are going to the mall because they can't be doing anything outside in February. Maybe people are hanging out at the mall or going out to shop for Valentine's gifts for their sweetheart. And there's a lot of different things that it could be that are causing February to be the highest month of sales. We don't know, but we can make some predictions or draw some conclusions based on what we know about life and what this graph is telling us. Okay, so any of those would be reasonable conclusions to draw for why February had the most coffee sales. Maybe that was the month they came out with a new flavor. Who knows? Okay, so there's a lot of different possibilities, and we just have to kind of come up with something that seems reasonable to the situation. Looking at this graph here, we've got the birthdays of all the DDHS geometry students on this graph. First question is, how many students are in geometry? Well, if this shows the birthday of every student, we can simply add them up. So in January, there's 3. In February, there's 4. In March, there's 2. In April, there's 3. In May, there's 8. In June, there's 10. July is 6. August is 1. September is 7. October is 8. November is 4. And December is 7. Okay, all I'm doing is looking at how far each bar goes up. Notice on the left-hand side, it says number of students and it goes by 2s. Be careful about that. So like January is in the middle between 2 and 4. That's how I know that that's 3. Okay, so let's add all this up here. Let's see, 3 plus 4 plus 3, that makes 10, 20, 30, 40, 55, 56, 63. 63 students total. Now the question is, what percent of students were born in the summer, June, July, and August? So I'm going to look just at these 3 months and see how many students that is. So August has 1, July has 6, and June has 10, which when I add them all up equals 17. Out of 63 is what percent? Okay, and we want to be able to figure this out. So we're going to set up a proportion to do that. I'm going to pull up my calculator here real quick. And I am going to multiply 100 times 17, and then I'm going to divide that by 63, and I get 26.98%. Let's round that to a nice even 27% of students are born in the summer. Okay? So hopefully that makes sense. We can figure out different percentages. I could have asked what percent of students are born in the school year or in December or whatever. We would simply take that and set up a proportion with the total amount of students we found. Hopefully this is making sense for you. Again, if you have any questions, let us know. But this is all about bar graphs. So just read the graph and figure out the information.